If you've used an AI video generator, you know the drill. You carefully type out a text prompt, hit generate, and wait hours while your computer chugs away, only to finally get back a warped, unusable clip. Runway and NVIDIA are trying to eliminate that wait entirely. They recently previewed a new model called GWM1, which produces high-definition video with a time to first frame of under 100 milliseconds. You aren't ordering a single static clip anymore. You're essentially holding a virtual camera inside a live, responsive digital environment. Hitting that sub-100 millisecond mark crosses a critical human threshold. It turns AI video from a slow, offline rendering job into a fluid, interactive medium that you can steer while it plays. To pull this off, GWM1 uses an autoregressive architecture. Autoregressive means the model generates the video frame by frame in a continuous stream, rather than trying to process the entire chunk of video all at once. This chart shows the massive hardware required to make that streaming approach work. You can't run this on a consumer laptop. It requires rack-scale systems, like NVIDIA's upcoming Vera Rubin platform, like the NVL72, networking dozens of GPUs to process every frame instantly. Think of it like playing Grand Theft Auto, but instead of a traditional physics engine calculating polygons, an artificial neural network is actively imagining and rendering the streets, the lighting, and the cars live in response to your steering wheel. Achieving this level of interactive speed requires a massive integration of specialized streaming software and cutting-edge data center infrastructure. In its current simulation mode, GWM1 can output up to 2 minutes of continuous video at 720p resolution, running at 24 frames per second. But the real upgrade is how you control it. Instead of relying solely on text prompts, you guide the model using what Runway calls actions. You feed it exact camera poses, specific robot commands, or live audio streams to dictate what happens next in the simulation. Say a director is mapping out a car chase in Tokyo. They start the scene, watch the cars drift, and without stopping playback, snap the camera angle down a side street to see the wet pavement. By letting you direct while the footage is actively generating, it removes the old trial and error process entirely. Pre-visualization becomes a playable, real-world sandbox. Runway is already rolling out this technology through an API called Runway Characters. This specific tool creates interactive digital avatars driven entirely by audio. Imagine a banking app where an AI customer service rep listens to a live audio feed of your voice. Based on your tone, the model generates a visual response on the fly, matching perfect lip sync with an empathetic gesture if you sound frustrated. Robotics companies are pushing this even further. They use these models to build synthetic training environments, letting them rapidly train the software for home assistant robots without needing to build dozens of physical testing rooms. Fast video generation allows engineers to iterate rapidly. It serves as a foundational simulator for training both digital agents and physical machines. Despite the speed, the model still struggles with logic. Runway documents frequent causal reasoning errors, meaning the system might show an effect before the cause, like a door swinging wide open a split second before a hand actually presses the handle. It also suffers from object permanence errors. The AI simply forgets the physical consistency of an item if it gets occluded or moves out of frame. If you try to run a continuous generation for too long, you'll see drift. A character's jacket might subtly morph into a sweater, or the lighting might shift directions. Plus, any network jitter or latency spikes will instantly shatter that smooth 24 frame per second illusion. The system instantly generates a highly convincing visual simulation, but it lacks a true underlying understanding of real-world physics. It still requires heavy human curation to keep the footage on track. This chart shows where Runway sits. Google Veo and Meta's MovieGen produce beautiful clips, but are firmly locked into an offline render and wait workflow. Even self-hosted open-source systems like Stable Video Diffusion take minutes per job, not interactive live feeds. Delivering a live feed requires an always-on GPU allocation for the entire time a user is connected. That completely shifts creator economics from billing per second of exported video to billing per minute or per session of active use. Moving to real-time AI means creators have to rethink their entire operational pipeline,
from how they budget cloud compute time to how they capture and edit live takes in post-production. Zero latency generation introduces a massive moderation problem. When content is broadcast instantly, harmful imagery, deepfakes, and non-consensual impersonations slip out before traditional safety filters have time to catch them. Governments are already reacting. The US and the UK have moved to criminalize the creation of sexually explicit deepfakes and are pushing strict takedown requirements for platforms that host them. To defend against this, Runway uses C2PA standards. C2PA is an open technical standard that binds cryptographic metadata to digital media, creating an invisible watermark that acts like a verifiable nutrition label. This perfectly aligns with upcoming European Commission transparency regulations. As the barrier to creating convincing fake realities drops to zero, strict digital provenance and verifiable metadata become the only reliable ways to verify what we see online. For enterprise users, access to this technology is closely tied to hardware availability. NVIDIA's Vera Rubin systems are scheduled to hit major cloud providers like AWS in the second half of this year. The traditional workflow of prompting and waiting for pre-recorded clips is on its way out. The next generation of creators will be the ones who master live directing inside these responsive, AI-generated worlds. We want to hear from you. What is the very first movie scene or game environment you plan to build when you get access to this technology? Let us know in the comments below. And don't forget to subscribe, like, and share. The line between operating a video game engine and aiming a film camera has permanently vanished.